Good morning. I'm happy to welcome you to this class. In this class, we want to discuss about taking off of the substructure. As I've said, substructure is the structure beneath the building underground. So when you talk about this taking off the superstructure, I hope all of you knows how this format is. It's called the dimension sheet. It is called the dimension sheet. We have column A, B, C, and D, where A is the dimension column, B is the entry column, while D is the sum column, C is the sum column, while D is a description column. So all our measurements will enter into column B. While if these items are more than once, we'll multiply that numbers in the dimension column, this is B, but for the C is for the sum of A times B, while D will have to describe what we want to measure or what we want to take off. So according to the diagram that we have been touched in the file, we have been told to take off a superstructure. So the first thing you take, take off superstructure, all provision. The reason why we say all provision, because we are going to measure things under the ground and we don't know their uncertainty. We can say the rocks will be after 2 meters, but for the real sense, after measuring, by the time we will be going to the real field, we can get these rocks maybe at 50 millimeters below. So that's why we say all provision, because we are not sure what we are measuring, if it is the same what in the field. So the first thing, when we are taking off, we must have what is called a checklist. A checklist is what will guide us at what are we supposed to take off. We must have a checklist. A checklist is a guide. It will tell us what we are supposed to measure. And you refer, I've said in the checklist, refer to the checklist attached in the file. There's a checklist that's been attached, so you refer to that checklist. So the first one is determination of the center line. The determination of the center line can be like getting the parameter of that figure. Parameter, all of you knows that it is length times width. So according to that, we started with the external wall, where we have the external wall, we have external length and the width. On the external length, we have 3 walls which measures 200 millimeters each. We have these walls which measure, they are 3 number, but the thickness is 200 millimeters. So it is 3 by 200, which give us 600 millimeters. Then we have another wall which measures 55 millimeters, and we have another wall which measures 6,000 millimeters. So the total length will be 12,100 millimeters on the external, the extreme length. When we come to width, we have another 3 walls which measures 200 millimeters each. So if we want to get the total measurement of those 3 walls, we multiply 3 by 2 to give us 600 millimeters. Again, on the width, there's a wall that measures 4,500 millimeters. Again, there's another wall which measures 5,000 millimeters. Then we have a wall which measures 6,000, but it's half of it. So it's half of 6,000, which is 3. If we sum all of these, will give us 13,100 millimeters. So if we want to get the total center line, is length plus width, but we use the parameter which is 2 into length plus width, which will be 2 into 12,100 millimeters plus 1,300 millimeters. Then you multiply the sum by 2, which will give you 50,400 millimeters. But there's another, we less to corners, because we have 4 corners, we say less 4 corners. If we have a number of corners to be 10, then we could say less 10 times 200, because all this wall measures 200 millimeters each. So it is less number of walls times the thickness of the wall. If the thickness was supposed to be 100, then it could be less 4 into 100, which we should have subtracted 400 from this center line. So our mean gap center line will be 49,600 millimeters. So this is the center line that we're going to use for measuring the for the excavation of the strip. For the concrete, we'll be using the same length, because all the excavation, this will be our length, and the width of the foundation will be our width, and the depth will also use for depending on the thickness of the concrete we're going to use. So on our first item, we have been told that the site is bushy. That's what we have been told. The site is bushy. So we need to clear that site. According to our checklist that I gave, the site is bushy. So if the site is bushy, means we have to clear it off. That site, we have to clear it and make it clear. So when we are talking about site clearance is always measured into square meter. Site clearance is always measured into square meter by taking the extreme length and the extreme length. Extreme length and the extreme width. So from the first item, which is site clearance, say clear area of site, by cutting down trees and edges as directed by the site manager or project manager, as directed by the site manager or the project manager, depending on the instructions we will be given. Sometimes you can be given instruction that you clear them, you store those firewoods for timbering, because you can use them later for timbering the site if you cannot have timber. But we are talking about the site clearance. We can get some edges of the trees, So trees are grouped into different forms. Trees are grouped into different forms. So on the trees, we have trees that have a mean girth of 200 millimeters girth. From 0 to 600 millimeters, we treat them as bushes. We will treat them as bushes. But any trees that is more than 600 to 900 millimeters are grouped at the same, when trees from 900 millimeters to 1200 millimeters are also grouped the same. This is what I'm saying. Well, if so, trees grouping, say from 0 millimeters to 600 millimeters, all these things are grouped together and they are treated as shrubs. We not cost for them. They are treated as shrubs. The girth means the diameter of that tree. If any tree lies from the diameter lies from 0 millimeters to 600 millimeters, that tree will be treated as a shrub and will not be quoted. But from 600 millimeters to 900 millimeters are also grouped together. So whether it is 650, 610, all these trees are grouped together. And you describe, cut down eucalyptus tree of diameter. You have to, on the description, if any tree was there, you have to give that description that cut down these trees of diameter, this from this, and the number you put where it is necessary. From 900 millimeters to 1200 millimeters are also grouped together. So on the second item that we are going to discuss after site clearance, we have excavation. When we talk about the excavations, excavation is being grouped into groups from 1.5 millimeters and below. From 1.5 millimeters and below. So we have from 0 to 1.5 meters. We have from 1.5 meters to 3 meters, 3.0 meters. Then we have from 3.0 meters to 4.5 meters, and also from 4.5 meters going to 6.0 meters, depending on the depth we want to excavate, depending on the depth we want to excavate. So excavation is done into cubic meter. All excavation is done into cubic meter, meaning it is depth, it is the length of excavation, which of course we'll be using the center line that we have gotten as the length. Then width, we'll be having the width of the trench, which is normally 600 millimeters, the standard one, and the depth depending on what you want to excavate. So the first one is the excavation of the topsoil. When you are excavating for the topsoil, it is recommended to excavate up to 300 millimeters. Up to 300 millimeters, but averagely it is always 150 millimeters deep. So on the description column, on the entry column, let's go for excavation. Let's start excavation. Excavation. Say length equal to center line, width to be 600 millimeters, and depth depending 300 depth, D to be 300 millimeters, but normally it is 150 millimeters. So you say excavate vegetable soil not exceeding 150 millimeters deep from the existing level. So on our description, the length will be 49.60, while on width will be 0.6, and the depth will be 0.15. Then you close that your entry. So all the entries will flow the way they are, depending on what we are going to take off, as I have attached in the file. So the major thing is to know how to take off, how to determine the center line, but majorly the key thing is on the description. Any item should be fully described. For example, when we talk about the concrete is also being measured into cubic meter. Concrete is also being measured into cubic meter. Assume you wanted to take off, there's a file, the way I've done it. Let's go for the columns. Concrete for columns. Concrete for columns. The length or the height of the column to be 27 millimeters. The column to be of 600, size of the column to be 300 by 450 millimeters. 300 by 450 millimeters. So that's what is measured. So our length will be 450. Length to be 450 millimeters. Width to be 300 millimeters. While our depth or height to be 2700 millimeters. 2700 millimeters. So on our entry column, this is what we enter. We enter 0.45, then 0.30, then we enter 27.00, then we close our entry. If these columns they were assumed there were 5 number of columns, then on the termination column we put 5, meaning we have 5 columns in such 5 number of columns, same size in that structure. So on the description now on the column, we have to describe what type of the class of the concrete we are going to use. We have to describe the type of class, concrete class. Assume, say 1 to 3 to 6 reinforced, vertical, concrete. Reinforced concrete, yeah, it should be reinforced concrete on vertical columns. On vertical columns. Meaning, this is the class 1 cement, 3 sand, and 6 ballast. That's the mix of the concrete. But it is reinforced, meaning it has some reinforcement bar. So the rest of the other, when we are going to do about the reinforcement, let's do about the reinforcement. That's another issue. Reinforcement to columns. Reinforcement to column. First of all, you have to determine reinforcement size. Assume D10 for the main bar and D8 for stirrups, all the legs. So the length will determine the length of the column, which was supposed to be 2700 millimeters. On the width, we don't have the width there. If you get then you say assume links or stirrups are placed at 300 millimeters center to center. So on the number of stirrups, so number of stirrups is equals to total length, which is 2700 over 300 plus 1, because center to center, giving us 8 number of stirrups. The length of the stirrup is equals to length of the stirrups will be 450 plus 450 plus 300 plus 300, 900 plus 600, which is 1500 millimeters. 1500 millimeters. So on when we want to enter that item, you say D10 reinforcement bars to vertical columns. Then say again D8 stirrups to ditto. Ditto means to the above or whatever is discussed. So on our termination column, we have gotten the length of the stirrup to be 1500. So it will be 1500. It is 1500 is 1.50 millimeters, but they are 8 in number. Again, columns are 5, meaning number of columns in the room times number per column times this length. So on our summing column, we'll multiply 8 by 5 by 1.5. This is what we'll be having. On this one, we have the length was 2.7 millimeters, but we know that every column to be 4. So there are 4 in one column, but we also have 5 number of columns. 5 number of columns. The rest will flow, and hope any query you'll raise. Thank you.